Here we have a question from Digital SAT Test 1, Math Module 1, question 26, which you can get on College Board's website. And we're given two linear equations, and we are asked about a point that lies on the graph of each equation. In other words, a fancy way to say a solution. And when you're dealing with the number of solutions for two lines, if you've been following our videos over the years, you've seen this a few times. There are three ways two lines can interact. They can hit once, they can hit never. Last but not least, they can hit all the time. That's the idea of having one solution, no solutions, or infinite solutions. And one of the most dependable ways to figure out which of these it is by just getting them both in the y equals format, and then you can find out the slopes and the y-intercepts and judge which of the three situations it is. Because if there's one solution, that would be because the slopes are different. That's why they're hitting, because they're not tilted the same way. If there are zero solutions, it's because the slopes are the same, but the y-intercepts are different. And if there's infinite solutions, it's because the slope and the y-intercept are both the same. Everything's the same because they occupy the same space. So to get to the bottom of this, we'll go ahead and set the two y's equal, or set them both in the y equals format. So for the first one, 2x plus 3y is 7, and just take away 2x from both sides. Divide by 3 on both sides. And that's our y equals mx plus b. And for the second one, we can take away 10x from both sides. Then we can divide both sides by 15. If you divide by 15 here, divide by 15 there, divide by 15 there, you'll get negative 2 over 3x, because you can divide those both by 5, plus 7 over 3. And something a little surprising is now happening, that they are both the same equation as one another. Now, you might have also just simply noticed that to get from the first equation to the second, you're multiplying by 5 consistently across the board. That means that these are equivalent equations from the beginning. And you might have picked up on that, or you might do what we just did and get them in the y equals format and then notice that they're identical. So what we're talking about right now is we have this situation, infinite solutions. The slopes and the y-intercepts are the same. Now, what does it mean for there to be infinite solutions? It means that the equation of this line, that itself is the solution. How could the solution be a line? That's because any point on this line is part of the solution, and there are infinite points that can be on that line. So the solution set is a collection of an infinite number of points that are all on that line. So that's actually a regular everyday SAT concept from the 2016 to 2023 SAT, but starting with this new 2024 SAT, the difference is the way it's being delivered. These x and y values, I'm just going to go ahead and highlight all the x's in the answer choices and highlight all the y's, because I think one of the things that makes this a little more challenging is that the answer choices are kind of hard to read, because look, you have the x values there being really, really tiny, and then you have them here being really giant. And I know from students that I've worked with that part of the difficulty is exactly that, differentiating what we're seeing in these answer choices here. So those are all our x values of our answer choices, and these are all the y values of our answer choices. So notice in answer choice B, it's really tiny. In C and D, they're bigger. In any case, What we need to do to figure out which of these matches the answer that we already have is solve for y, which we did already, and then actually solve for x as well. So if we're solving for x, we can take this equation that we have here, which is kind of the basic standard form equation of all this, and instead of solving for y, let's solve for x. So take away 3y from both sides, and we'll have negative 3y plus 7, and divide by 2 on both sides. We'll have negative 3 over 2y plus 7 over 2. So now, understanding this a little bit better, we've got y equals negative 2/3 x plus 7/3, and if we have it in x equals, it's x equals negative 3/2 y plus 7/2. Now let's verbalize this. The y value is what you get when you multiply x by negative 2/3 and then add 7/3 to that. And looking at this one here, the x value is what you get when you multiply the y value by negative 3/2 and then add 7 over 2 to that. And it's wild and crazy, but this is what's going on in this question. Which answer matches either of those? And it's answer choice B that matches these, because in B, you have your y value, which is r, and then you have your x value right here, which is what you get when you multiply the y value by negative 3 over 2. So you're multiplying r by negative 3 over 2, and then adding 7 over 2 to that. So the big takeaway on this question is to see that this is kind of a fancy way to say this, and that's why the answer to Digital Test 1, Math Module 1, Question 26 is B. Thanks a lot, and have a great day.